Hi, Assalamualaikum and good morning. My name is Nunajim Atira Saimi, and today I will be presenting about the summary of Chapter 2, Vector Analysis, and Chapter 3, Static Electric Field in this course. Okay, in this presentation, this is really important because they help us to understand how electric field and charge behave in engineering and physics. So, let's start. Okay, this is the outline of my presentation. So, I will be present one by one and let's go to the first topic. Okay, now let's go to the first topic, which is a vector analysis. Okay, so first one is scalar quantity. Scalar quantity has only magnitude and no directions. Like example, temperature, time and energy. While a vector quantity has both magnitude and direction. For example, like velocity, force and electric field. So we know vector can be written using x, y and z components. The magnitude of the vector is calculated using a square root of the sum of the square of its component. To find direction only, we use a unit vector, which is obtained by dividing the vector by its magnitude. Okay, next, position vector and distance vector. A position vector represents a location of a point measured from the origin, while the distance vector represents the displacement between 2 points. Finally, there are two important vector operations, dot product and cross product. For a dot product, give a scalar value and is commonly used to find an angle between two vectors, while the cross product gives another vector and is useful for determining a vector that is perpendicular to two given vectors. Let's move on to the orthogonal coordinate system. There are three main coordinate systems used in physics. So the first one is Cartesian coordinate system, which is used x, y and z axis. The second is the cylindrical coordinate system, which is used rho, phi and z. It is mainly used for a cylindrical object like a pipe and a wires. The third is spherical coordinate system, which is just r, theta and phi, and it is suitable for the spherical objects. We can also convert coordinate system for one system to another system using a transformation equation. Different formula are used to calculate the distance between the 2 points in each coordinate system. We need to choose a correct coordinate system to make a calculation easier and more efficient. Okay, next is a vector calculus. Before introducing of the operators, let's look at the basic concept of vector calculus. These include a differential displacement, differential of normal area, and differential of volumes. These basic elements are used to describe a small change in distance, area, and volume in different coordinate systems. Okay, next move to the del operator, also known as a lambda. It's a vector differential operator used to calculate a gradient, divergence, curl, and Laplace. Okay, so the first one is divergence. All of the formula is to measure the net outward flow of a vector field from a point. However, the curl part is measure the rotation or circulation of a vector field around a point. Action of the slide, this concept and operator have different formula in Cartesian, cylindrical, and spherical coordinate system. Lastly is a Laplacian. Laplacian is describe how a scalar field changes around points. So that also have a different formula for a Cartesian, cylindrical, and spherical coordinate system. Okay, next I will explain about the static electric field. A static electric field is an electric field produced by stationary electric charge. Electric charge can be positive and also can be negative, and the unit SI is a coulomb. Okay, move on to the Coulomb's law. This law explains the electrostatic force between 2 point charges. As shown by the formula on the slide, the force increases when the charges are larger and decrease as the distance between them increases. Next is electric field intensity. It's the force experienced by a unit positive charge. For a point charge, the formula is also shown on the slide, and its SI unit is a Newton per coulomb, or distribution, we use a charge density to calculate the total charge. There are three types like line charge density, surface charge density, volume charge density. As shown on the slide, also the total charge is obtained by integrating the charge density over the corresponding line, surface, and volume. Finally, let's discuss the electric field due to the charge distribution. When charges are continuously distributed, the total electric field is calculated by adding the contribution from a very small charge elements. As shown on the slide, there are different formulas for a point charge, line charge, surface charge, volume charge, and the infinite sheet of the charge. Next is the electric potential. This is defined as the volt time per unit charge to move charge from the one point to another point. The relationship between electric field and electric potential is also shown on the slide when the electric field always point in the direction of decreasing a potential. Another important concept is electric flux density. It represents the amount of the electric flux passing through a unit area perpendicular to the electric field. So, lastly is Gauss' law. States that the total electric flux through a closed surface is equal to the total charge enclosed by the surface. This law helps simplify the calculation of the electric field, especially for the symmetrical charge distribution. Okay, thank you very much for your attention. I hope this presentation has given you a better understanding of the basic concept of vector analysis and static electric fields. So, bye!